Hello geometry folks, welcome to our next lesson is on angle pairs. Just wanted to take a minute before we get started here and remind you that your notes should look exactly like my notes. Everything I write down, you write down. If there's ever a question, write down everything. And when I come to a journal check, I should be able to see exactly what I'm writing down. Also, please utilize that pause button and be able to rewind me if need be for any point. If you didn't quite get what I was saying or didn't make sense or you just want to hear it again, please do that. It's your responsibility to understand what these notes encompass. All right, hopefully today in class or whenever you were in class, we were able to set up your foldable. So this piece of paper here is actually the inside of the foldable. Pretend that these flaps here are folded over. On the outside of the foldable, we'll have the topics or the angle pairs. So this first one on the outside is vertical angles. And so on the inside, on the left-hand side, we're going to put some examples of what they look like. So if you want to put examples at the top, and on the right-hand side, we're going to put some definitions. All right. So first, I'll give some examples. If we have vertical angles, a good example of that are two lines that cross each other in any way. All right, and being lines, they have arrows as well. All right. So any two lines that cross each other, and the vertical angles are across from each other. So on these lines, this angle here is vertical to this angle here. And also, if we have one set of vertical angles, I have a second set of vertical angles. Okay? The thing about vertical angles, and as you might be able to tell here, is that vertical angles always have the exact same measure. Vertical angles are congruent. So over here on the definition, I can put a big old asterisk and say that vertical angles, and I'm going to abbreviate here. There's an abbreviation for angles. It's the angle symbol with SN inside. Vertical angles are always congruent. There's a symbol for that as well, equal sign with a squiggly on top. Okay, so if on our diagram over here, if on our example, if I would number these angles, this is angle 1, this is angle 2, this is angle 3, and this is angle 4. Since vertical angles are always congruent, I know that that angle 1 is always going to be congruent to angle 3. Therefore, the measure of angle 1 is going to be equal to the measure of angle 3 every time. Also, I could say that the measure of angle 2 is equal to the measure of angle 4. Whatever is represented there, whether it's an individual angle degree measure or if it's an algebraic expression, they're equal to each other. Okay, and our next type of angle pairs are complementary angles. On the outside of this flip will be complementary angles. The definition of complementary angles, put an asterisk, it's a hard word to say, it's hard to draw as well. An asterisk are two angles that add up to 90 degrees. Two angles that add to 90 degrees. All right, so we can give an example of that. If I have a 90-degree angle just by itself, okay, and that doesn't look like a 90-degree angle, but check this out. It is a 90-degree angle because I put the symbol on there. Since with that symbol, I know it is a 90-degree angle, okay? One 90-degree angle, and if I had two angles that were together on that, I could call this angle 1, and this is angle 2. Angle 1 and 2 are complementary angles, okay? Another way I could have this, since these angles are adjacent, they don't have to be adjacent. I could also have just an angle here. I'm going to say that this angle is 30 degrees. Okay? And another angle that would be complementary to that would be 60 degrees. So if I had a 60-degree angle, okay, so we can put both those angles in there. And I know that those two angles are complementary. So they can be adjacent, but they could also be separate and therefore be complementary. So the way I like to write this out, since we have two angles that add to 90 degrees, I can say the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Okay? That's a geometric statement that I can say. We're going to refer to that later on. So in this example, the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. All right, our next type of angle pairs are supplementary angles and linear pair angles. This is on the outside of the flip. Supplementary angles by definition are two angles. Let me use my angle symbol again. Two angles that add up to 180 degrees. Two angles that add to 180 degrees. Okay? An example of that, if they were together, well, let me draw them separate first. Let's say here I have a 30-degree angle. Okay? What would the supplement of that angle be? Well, 180 minus 30 is 150, so it's going to have to be a 150-degree angle. All right? Another type of supplementary angles is that linear pair. And linear pair, let me give you the definition of that, two adjacent and supplementary angles. I'm going to abbreviate that with SUPP. Supplementary angles. Okay? So think about what that would look like. Two adjacent and supplementary angles. Okay? They add to 180 and they're adjacent. Adjacent means right next to each other. So these are going to be on a straight line. Hence the word linear pair. You can see that is on a straight line. So a straight line, the degree measure is 180 degrees. We can know that because it's comprised of two 90-degree angles, or all the way around is 360 degrees in a circle. So half of that is a straight line going through it. That's 180 degrees. Okay? So just if I would split that into two angles, and I call this angle 1 and angle 2. So angle 1 and 2 are a linear pair. So again, over here in the definition, I could say the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Okay? Just one more quick example of that, if you want to draw this in there. That if we had just two lines that cross each other, this is our vertical angles again, but actually with our vertical angles, 1 and 3, then 2 and 4, I also would know that angle 1 and 2 are a linear pair and therefore supplementary. 2 and 3 are a linear pair, 3 and 4 are a linear pair, and 4 and 1 are a linear pair. So just notice that we could also have that relationship with two lines that cross each other.